I'm Noelle Bakhtian from Lawrence Berkeley National Laboratory, Executive Director for the Berkeley Lab Energy Storage Center. As you know, the Bay Area Summit is hosted annually by New Energy Nexus, CalCharge, and as the core members of CalCharge, we, the national labs, wanted to make sure that this community is aware of the partnering opportunities provided by our organizations. I'll start with sharing Department of Energy and National Labs 101 and why you might want to partner with us. Then I'm going to turn it over to Tony, Johanna, and Gao, who are going to represent our storage subject matter experts at the labs. Yike will then give you a flavor of how to partner, and then we're going to do a little bit of Q&A discussion where I'll be providing you a 60-second survey that will provide matchmaking tool to help you all matchmake with a lab. With that, I'm going to start with 101. So the US Department of Energy ensures our security, prosperity across the nation by addressing energy, environment, and nuclear challenges. What many don't realize is that Department of Energy owns and funds a set of laboratories across the country that are really the workhorse, together with industry and academia, for researching and developing the science and technology solutions to address those challenges. The labs steward really unique science and engineering capabilities, whether it's facilities, equipment, instrumentation, that serve tens of thousands of scientists and engineers from all sectors. There are 17 national laboratories across the Department of Energy system, shown here, each managed by specific offices across the Department of Energy. That's what the different colors mean. Note in particular the concentration of labs in the Bay Area, and we're going to come back to that. Even before I started working at a national lab almost 4 years ago, I knew that the lab system is one of the, if not the largest research system in the world. And the DOE national labs are widely considered to be the crown jewels of the US research enterprise. Now, here's the part that people don't always realize, that the national labs are really federally sponsored. They're here to serve the national interest. They're paid for by your taxpayer dollars, and they're not competitive with industry, which means at the end of the day that they host one-of-a-kind world-class capabilities and expertise that are on your doorstep, ready and waiting to collaborate with you. That is really good news. And oops. And what that means for you is that you have access to accelerated research and development via lab experts, via specialized and unique research capabilities and facilities, via transformational technologies, ideas, and patents. It also means that available to you are co-research opportunities, including some of your personnel can actually be embedded into a national lab via one of our affiliate processes. And at the end of the day, we're also here to help you as collaborators supporting applications for grants and funding opportunities as well. So let's take one step back and look at what really makes California special when it comes to energy storage. California is leading the nation in energy storage procurement and installation. We've got 150 energy storage companies and research institutions across the state, most right here in the Bay Area. And we have Silicon Valley. That's all pretty special, but let's bring it together. So what you saw was the distribution of the 17 DOE national labs just a minute ago, but recognizing that California has one of the largest and most dynamic concentrations of energy storage players in the world, we as the 3 Bay Area national labs, Lawrence Berkeley National Lab, SLAC, and Lawrence Livermore National Lab, have come together under the CalCharge branding operated by New Energy Nexus to provide you with structure, value, and access to the national labs across the energy storage space. CalCharge really provides a bedrock for this incredible energy storage ecosystem here in California. So what is CalCharge? Well, you're going to hear more about it in just a few minutes, but at the very highest level, CalCharge is a battery and electrochemical energy storage membership program comprised of startups and world-class companies, research institutions, labs, and other key stakeholders across the world. CalCharge program manager Yike is going to deep dive on that. But first, I wanted to make sure that everyone gets a double click on each of the national labs so you can each get a sense of what you could gain through partnership. Something to keep in mind, these 3 labs alone represent almost $4 billion in annual investment and over 13,000 staff and researchers with over 1,000 facilities. So with that, I'm going to turn it over to our panelists, starting with Tony Van Buren, who is the Deputy Division Lead for Science and Technology at Lawrence Livermore National Lab. And I'm going to stop sharing.
All right, well, thanks, Noelle. So I'm working at Lawrence Livermore National Lab, and I am the Deputy Division Leader for S&T and Material Science, but I'm also the Program Leader for the Energy Materials effort at the lab. And I'm really excited about sharing some of the opportunities and areas of research that we have going on presently. So I showed this in my earlier talk this morning, but I'd like to highlight, maybe take one topic area from each of these areas. Our energy materials is focused on 4 different areas. Materials systems, in particular looking at solid state batteries, supercapacitors, zinc electrode batteries, that's zinc air and zinc manganese oxide rechargeable systems, and architectures for flow batteries. We also have a very large effort looking at architected and optimized structures. So what does that actually mean? We're looking at topology optimization of material structures to enhance performance metrics. So in other words, that's like, how do you put something together in 3 dimensions to optimize performance? So this goes hand in hand with the efforts that we have at the lab doing 3D printing of energy storage materials, where we can actually print the topology optimized structure to see, is it actually performing the way you think it should be performing? We have a large effort looking at interface and degradation modeling. Some of the largest computers in the world reside at Lawrence Livermore National Lab. So efforts in multi-scale modeling, reactive interfaces, closely coupled theory and characterization efforts, and looking at degradation and processing science. Other energy storage systems include hydrogen-based grid storage, thermal energy storage, using the explosives testing facilities for safety testing, and of course, our main mission, doing battery and energy storage for DOD and NNSA applications. So I'm going to just touch on, like, quickly one topic area in each of these areas. So in the material system, Livermore has developed the ability to print solid state electrolytes. This is en route to a printable all solid state battery. And here our efforts are really focused at changing the architecture of the solid electrolyte at the solid electrolyte cathode interface to improve contact and performance. We have a large effort, as I say, in optimized structures. This movie that is playing is showing the flow patterns and optimized surface area for a flow electrode. Flow is going from left to right, and it's predicting a structure that would have optimized flow and optimized surface area for an enhanced electrode for a flow battery. And then you can see over on the right, we get a 3-dimensional rendering of that optimized flow battery, and then we proceed to print that flow battery and test. So in this case, we're looking at flow batteries for our hydrogen bromide flow battery system, and we're predicting both a 35% lower overpotential with these in these systems with these architected engineered structures. Multi-scale HPC is like a strength at the lab, and we're using interface simulations to guide improvement in battery operations and manufacturing, particularly looking at degradation and transport phenomena at the interfaces between solid electrolyte and electrodes in solid state batteries, and looking at processing science to understand how co-sintering and processing of solid electrolyte material can improve the materials performance of solid electrolyte or solid state batteries. This is in conjunction with a much larger multi-lab consortia that is looking at sort of using the same computing infrastructure to look at hydrogen, or the needs for hydrogen economy. Livermore is part of the Highmark facility. That's materials for compact, energy efficient storage of hydrogen fuel, hydrogen for new avenues for producing renewable hydrogen, and H2New for durable chances for large-scale manufacturing of electrolyzers. So Livermore is leading this effort, so in the greater hydrogen storage community. The energy materials facilities, I just point out 3. I talked about them earlier this morning. The Laboratory for Energy Application of the Future, the Advanced Manufacturing Laboratory, and the High Performance Computing Innovation Center are all facilities that sponsor our external engagements with industry and other partners in the energy storage future. Thank you very much for this brief overview from Lawrence Livermore National Lab. I will pass it on.
Thank you so much, Tony. And with that, I'm really pleased to be able to introduce you to Johanna Wecker, who's a staff scientist at SLAC National Accelerator Lab. Over to you, Johanna.
Thank you. So SLAC National Lab is a multi-program lab. We have a number of user facilities, and one thing I want to point out is that means that we have over 2,500 users coming on site every year to use our unique equipment and our unique X-ray probes. We are basic energy science funded for the most part, yet our research spans many different problems, going from discovering things about the universe all the way down to how materials work at the finest length and time scales. With this trying to understand materials across these length scales down to the finest length scales, we have a number of user facilities that use X-rays and electron probes. 2 of them I want to highlight today are the Sanford Synchrotron Radiation Light Source, or SSRL. This is a synchrotron that produces high flux of X-rays. With this synchrotron, we have a number of different instruments on it, which can probe different parts of the materials. And we really focus on doing our probing of materials in situ and during operation. So for example, we can characterize materials as we synthesize them, and we can tweak our synthesis depending on what we find with the X-ray probe. We also do characterization during operation. So for example, here, this is characterizing a battery while it's operating. So we can see, how does a battery operate in normal conditions? How does it fail? What are those failure mechanisms and pathways towards failure? And the second user facility I want to highlight is our cryo-EM facility. This is a very new facility that we just opened up with funding help from Stanford University, but it is open access to all users, including industrial users. And with this, we can do cryo electron microscopy of materials. Typically, people think of cryo-electron microscopy for biological materials, but there's a lot of radiation-sensitive materials like lithium that you want to investigate at very high spatial resolution. So here, for example, are cryo-electron microscope images of lithium dendrites, and you can see the individual lithium atoms in their lattice structure. We have also just recently opened up our Argonne Science Center. This building hosts labs that have battery material synthesis, battery fabrication, and testing. I also want to note that the 3rd floor of this building is actually very empty. It is currently just a shell that could potentially support new collaborations or large-scale facilities that we don't have yet. In the past, we have partnered with a number of different industries across many different research projects. There's 3 that I'd like to highlight. The first is with Lucid Motors. We looked at 18650 batteries while they were cycling and looked at the degradation mechanism inside the battery without having to take apart the battery. So these are the anode and the cathode of an 18650 battery. And we investigated that in their drive cycles. A second example is with Murata, where we looked at their lithium sulfur batteries and at much higher resolution on the nanoscale could see morphology changes as the sulfur changed chemical states, became polysulfides and cycled. And then finally, through a collaboration with a CRADA that we formed with Bosch, we looked at the state of charge in batteries as they were cycling. I can't show you the actual data for this because it is not yet published, but using X-ray diffraction, we could look at how the state of charge changes with depth through a material, a cathode material, while cycling. A final thing that I want to highlight is our research in the electric grid. So we have a large effort trying to convert our really 20th century electric grid to the 21st century. And this is really necessary as we evolve into more complex energy sources like wind and solar. And so a lot of this work is really focused on advanced modeling techniques and incorporating machine learning into our research. And so this focuses primarily on developing these new tools for optimizing the grid. So in summary, SLAC is a lab that's focused on energy and sustainable research that spans materials, catalysts, batteries, photovoltaics, the grid, and the intersection between water and energy. It is also unique in the DOE complex because both of its relationship very closely with Stanford University and also that it sits within Silicon Valley. Thank you.
Thank you so much, Johanna. With that, I'm really pleased to be able to introduce you to my colleague at Lawrence Berkeley National Lab, Gao Liu, who is Group Leader for Applied Energy and Materials within the Division for Energy Storage and Distributed Resources. Thanks, Gao.
Hello, everybody. My name is Gao Liu, and I am the Berkeley point of contact for CalCharge, and also I'm a staff scientist working on batteries. And DOE has a long history of supporting energy storage for transportation applications. So Berkeley Lab is actually one of the labs selected back in the 1970s to do energy storage for electric vehicle applications. So since then, we have been having almost 50 years of research experience in these energy storage for transportation applications, and now we're moving towards more of grid applications. And Berkeley Lab has a really big effort on the energy storage, including a $20 million annual funding, which focused on energy storage. And also, we have 5 national user scientific user facilities and doing research, 3 of them very much related to the energy storage at Berkeley Lab. And we have a division called Energy Storage and Distributed Resource Division, which specifically look into energy storage for vehicle applications, and now we're moving towards looking into grid storage applications. So we have labs, we have facilities, and I want to hear a summary of our capability in 5 areas. The first area is new material discovery, and the second is understanding performance for the materials and also for the batteries. The third one is we're going to talk about the lab scale fabrication testing. And then the last 2 would be a development simulations and also grid storage. So all of these are really focusing on energy storage per se. So the first one is new material discovery. So we have projects and programs looking into cathode material, anode material, and electrolyte materials. For the cathode materials, we look into high energy, high voltage materials. And on anode materials, we look at silicon-based and high capacity materials and also lithium metal-based materials. We also have solid state work going on. And one of the uniqueness of Berkeley Lab is we using computation and first principle based material discoveries for energy materials, for battery materials. And we actually heavily leverage the computational facility at LBL to do this. So the second thrust we have is understanding performances. After we have new materials, if user brought in new materials, so we think how these materials can fit into different chemistries and different applications. So we're using modeling-based analysis to look into these materials' performance. And for example, some materials are specific, can be used for electric vehicle applications. Some of them can be used for plug-in vehicle applications, and how these materials can use in different temperatures, how this can be used at different rate, and some of them can be used for the different type of systems. So those are really, we have a long history of doing that. We have several PIs doing this kind of research to bring the best out of the materials. The third capability we have is we can make lab scale coin cells, pouch cells, and we have over 1,000 channels to do testings of these cells. So along with this capability, we can also do electrode designs. So we can actually design electrode, design cells with specific applications. So the last two applications is, last two thrusts is really related to how we understanding batteries, how we understanding the battery performance in specific situation. For example, number 4, we have this development simulation system, which in Berkeley Lab, we have a laboratory called Flex Lab. So we can bring in batteries, bring in energy storage systems. We can run in a real life situation, so we can see how the battery performs. And number 5 is our grid storage capability and also grid integration capability. We can take the data, we test it in a real situation, and see how they can fit into certain applications. For grid applications, we can also tie in the electric vehicle into the simulation to see what would be the optimized usage of those batteries. And along with this, there are several DOE programs that support our effort for a very, very long time. And one is the called Advanced Battery Materials Program, which is a BMR program, which support our effort on material discoveries. And also we have Advanced Battery R&D program, looking into the battery, not only material discovery, but also looking at how the battery can be used, how the material can be used. And then we also, along with that, have 500 Research Consortium, we're part of that. And we're also part of the J. Caesars. And also worth noticing is the materials project, which is the computational based material discovery program, is actually originated from LBL and is having a lot of impact on battery discovery, not only at Berkeley Lab, but also in other labs and also worldwide. So if you have any specific needs, you want to talk to us, and I have my name here and contact information. Also, Catherine Britton is also our lead on the cloud charge at LBL. Also, you can email her too, and we're happy to work with you. And I want to give you one of the example how we typically work with companies. And Johanna talk about one of the companies she worked with, which is Bosch, which is a big companies. And as you know, the culture, we work with big companies and small companies, also startup. I want to use a startup example here, which the company name is called Corshell Technology. And the Corshell Technology is actually originally from Berkeley. There's 2 Berkeley graduates, and Jonathan Tan and also Roger Basu. They have a unique technology, is looking into surface coating to stabilize electrode. So the way that we were working with them is we have initial engagement with, they're from Berkeley, so I know them for a while, and then we talk about the technologies, and then I invite them to come to the lab to visit our capabilities. We have, the instrumentation for batteries, for materials, and we have technology discussions and to find out where their technology can be best fit for battery applications, right? They're not only talking to me, we have 13 PIs in the labs, they can talk to the PIs to actually getting into an understanding where their technology best fit for battery applications. So in that way, we identify a collaboration project, we sign an agreement. So that's how we, in the end, having a culture project now is ongoing. So I would say that at Berkeley Lab, we do 3 things, right, to help with startup, and also for big industry, we do pretty much the same thing. We do initial engagement and the discussion of technologies, and we understand, and we also help the company to understand and sharpen the value message based on the lab's many experts. And also, we're assisting the companies to understand where they can best collaborate with. Some of them are us, some of them are other labs or universities, and will facilitate this process. So that's how we do a task order at LBL, and how we work with small company. And I like all of you to contact us to be able to see how we can help you down the road. All right, with that, I want to pass on this to Yi, and she will talk about the ways how you can sign up task order for CalCharge. Thank you.
Thank you so much, Gao. And now with that, I am so excited to be able to turn it over to Yi Ke, who's the program manager at New Energy Nexus for Mobility and Energy Storage Program. She manages the entire CalCharge program, so you're in good hands with Yi. And she was also instrumental in organization of the entire Battery Summit. So we're very excited to have Yi's time today. Over to you, Yi.
Thank you, Noel. Hello, everyone. So if you heard the 3 lab capability, and you probably already have some idea of how you can work with the lab to benefit your R&D. So now, how did you actually collaborate with National Lab? That's where CalCharge comes in. CalCharge is founded in 2012, precisely to providing the fast track to collaborate with National Lab. So at the core, CalCharge is holding a collaborative research and development agreement, CREDA, with all 3 national labs you just heard about, and which is pre-approved by DOE. So, so far, there are 15 projects that's been taking place, utilize the CalCharge CREDA, and 3 projects kicked off this year alone. So you can do various type of projects under the CREDA, from material synthesis to characterization, cell assembling, battery testing, and computation modeling. Who are some of the companies who take advantage of the CalCharge membership? So let's review our member structure. First, we start with the core member, our partner, including the 3 national labs you just heard from. And then we also have a charter member, and also a large portfolio of a general member. So you can see we have a very strong existing membership foundation. But today we are talking to you really looking for new general member who are innovators, who can benefit from partner with National Lab, utilize the world-class expertise and resources to benefit your R&D. So I want to show you a quick description of how your journey to collaborate with National Lab would look like you under the CalCharge CREDA umbrella. So the main value proposition is, this is actually a very simple process. So you start from the very left of this flow chart, you sign a CalCharge member agreement, and also a CREDA access agreement to access the existing CREDA. And then all the box within the green is actually the internal lab processes. You will collaborate with the PI within the lab, while providing feedback and input. But the PI really are guide you through the process, and really a lot of that is not really, it's not added burden. But what you would see at the end is you will actually get the approval. If you are a domestic startup, domestic company, you would get approval within the national lab. And then if you are a domestic international company, then you will get approval from the DOE. And then you have a work task order in place that's attached to the existing CREDA. So besides the simple process, so as you can see, like the touch point really kind of in the legal burden for you is relatively small because all the CREDA is pre-negotiated. So in addition, that pre-negotiated CREDA give you a much shorter process time. So we have experienced that a domestic startup are able to start their task order within 8 weeks of the initial discussion with the National Lab. So that's substantial time reduced compared to the traditional CREDA, and which is, it's not uncommon that sometimes the CREDA will take a year. Also, the other benefit, unique feature of the CalCharge CREDA is that because each of your project is just a task order that attach to one big CREDA. So the budget size and the scale of the project can vary. And so that's probably the very good news for a startup, which so that you could envision a project with National Lab at a much smaller budget than a traditional CREDA that can accommodate. So another important benefit for the CalCharge CREDA term is that we provide a very strong IP protection for innovators who want to commercialize their technology. First, you have the first right of exclusive licensing for predetermined field of use. You also can invoke CREDA protection. So all the research that developed within the CREDA will not get published within 5 years. So just in summary, I think I hope I showed you the CREDA process within the CalCharge framework actually is very streamlined. It's a very minimum legal burden and for you as a corporate or startup. And also we have the pre-negotiated term that's really designed with innovator like you in mind. So with that, I highly encourage you to consider collaborate with us. I'm going to turn the floor back to Noel. Thank you.
Thank you so much, Yi. So with that, I wanted to share some websites here, some resources for you. We've got websites for CalCharge and each of our labs with contact information with each of the main POCs or set of POCs for CalCharge at our respective labs. So please reach out. We're here to be supportive and collaborate with you. I also mentioned matchmaking. I want you to definitely take a look at that link at the top. This is an easy way we've created for you to be able to get in touch with us after this presentation. You don't even need to email us. Just go to this link, fill out the form. It shouldn't take more than 30 seconds. I honestly promise you, we tried it. It takes 30 seconds. And it's just an easy way to get a call back from us and set up meetings with multiple of our labs or one of our labs, or even just to get more information. So with that, thank you so much for attending. And on behalf of the entire panel, we hope you enjoy the rest of the Bay Area Battery Summit. Thank you.